All right, this is quite an interesting question to solve. And of course, I'm sure we all have an idea of how to solve trigonometry equations if you've been watching our previous videos. But the difference with this particular one is we are having a complex expression as our angle. You can see our angle is written as theta plus 25. So in this video, I'll be showing to you how to solve questions like this. We'll be solving another example after this so you can get more familiar with scenarios like this. So very simply, of course, while solving this, the very first thing to do is to uh, bring out, make this the subject of formula. So we have theta plus 25 degree equals to, we have 2.532 minus 1. So that's the very first step to take. So we'll be having our 2 sine theta plus 25 degree equals to 1.532. All right. Now, this is something I have to explain right here. This theta plus 25 is actually the whole angle for sine. So before we used to write sine theta, in this case, in this particular case, the angle was theta. But in this case now, the angle is not theta alone. The angle is theta plus 25. So you have to deal with theta plus 25 as the angle associated with the sine, not just theta alone. So you don't isolate theta from 25. Theta plus 25 is actually the whole angle, is the angle associated with sine. So what you do here is each time you want to deal with, maybe you want to have arc sine, you will be having it in association with theta plus 25. Let me show you what I mean by that. Of course, in this case now, for us to go on, we have to divide both sides by 2 so that we can have theta plus 25. So this will be 1.532 divided by 2. So if you press that on a calculator, you'll be having 0.766. So we are able to arrive at sine theta plus 25 degree equals to 0.766. Now this is exactly what I'm trying to say here. Look at now, for us to find, we don't want to isolate theta plus 25, so rather we would have theta plus 25 degree equals to arc sine 0.766. So you take theta plus 25 as the angle, not just theta here alone. So in this case now, you can see that your theta plus 25 will give you 50.0 degree. So now we have been able to get our value for theta plus 25, which was the angle associated with sine. So how do we solve this? Of course, just so I remind you, this particular question, we have our condition set that theta was between 360 degree and 0 degree. So you have to investigate using your quadrant as usual. So when you go to this particular position, of course, we're dealing with the sine here, and the sign we have here, of course, you understand when I say sine and sine, this one is sine as a trigonometric function. This sign here is positive and negative. So looking at the positive side, there's a positive sign here. So obviously, we're interested in where sign was positive, and that's first and second quadrant. So now we have gotten our angle theta plus 25 equals to 50 degrees. That's the angle associated with the sine trigonometric function. So for us to get our final solution, I told you cannot get a final solution whenever you have a situation like this until you investigate using the quadrant. So we have the first quadrant and the second quadrant as a quadrant of interest. So what do you do here? Of course, for your first quadrant, the angle here will just be replicated. So you can say your angle theta plus 25 degree, don't forget this is the angle as we sine, is equals to 50 degree, 50.0 degree. And for your second quadrant, of course, don't forget the angle here is what you will be seeing this as the angle. the way you used to see theta here as the angle associated with sine, you'll be seeing theta plus 25 as the angle associated with sine here. So in this case now, what you're dealing with now, the general rule stated that in second quadrant, you're supposed to have 180 minus theta, and this theta here was representing whatever angle was associated with sine. That was what this meant then. So in this case now, you're dealing with theta plus 25. So it will be 180 minus theta plus 25 degree, which is the angle. This is like representing theta in when you used to have theta. If this whole place was theta, the way you were going to solve it is this is theta in that scenario. I'm sure you can follow me. So in this case now, we'll be having 180 minus 50, and that will be 130. Now, I want to also clarify something. What you have gotten as both of these answers was the value for theta plus 25, which was the angle associated with sine. This is not the value for this particular theta here. This theta you are seeing here is not 50.0. This answer here was for theta plus 25. So in this case now, because while trying to solve an equation, you're supposed to find the unknown. The unknown here is theta. So you have to then go on to find the unknown theta. So what will happen there is that you will say theta plus 25 is equals to 50. So obviously here, this your theta now will be equals to 50 minus 25, which will be 25. That's in the first quadrant. This will be your final answer for your theta, this particular theta here. And then for the second one, your theta plus 25 is equals to 130. So your theta here is equals to 130 minus 25, which is equals to 105. So this was the theta value here. Don't forget, this theta is not the whole of this angle, rather just a part of the angle associated with sine. So this is it right here, 25 degree and 105 degree. I'm sure you can follow. So this is going to be our final answer for theta, because while trying to solve an equation, you want to find the unknown. So the theta value here, which was the unknown, is 25 and 105. So in this question, we're told to solve this particular equation. And I want you to know that for this case, we have theta ranging between 360 and 0 degree. So this is similar to the previous question we just solved. And of course, the step to take is, the first thing to do is, okay, let's rewrite this here. So looking at this, the first step to take is to isolate this. So we have 2 theta plus 25. This was the angle. Don't forget what I said previously. In this case now, 2 theta plus 25 is the angle associated with cos. So you have to take it as a whole. You have to move them together. So it's not, you don't separate them. You can't separate 2 theta from 25 here, because 2 theta and 25, they are both seen as the angle. 2 theta plus 25 is the angle associated with cos. So you take it together collectively like this. This will be equals to arc cos of 0.454. So I told you already in previous videos that while solving equations like this, you want to first ignore the sign. So whatever sign was there, you will just act like you ignore the sign, then you go on to find the associated angle. So when you do the cosine of 0.454, what you're going to get is 62.999, which is obviously 63. So it's okay for us to write it as 63 degree. All right. So don't forget, this is the value for 2 theta plus 25 degree. So the next thing to do is to go on to investigate using your quadrant. So you want to find out what quadrant deals with. In this case now, you can see the sign here is negative. The sign here is negative. So you want to ask yourself, add sugar to coffee. Where is sign negative? Sign is positive in first and fourth. So sign is negative in second and third. So in this case, now we're dealing with quadrant 2 and quadrant 3. So quadrant 2 and quadrant 3 is our quadrant of interest here. Now quadrant 2 said 180 minus theta. That's the rule that goes on in quadrant 2. 180 minus theta. Now don't forget, this theta value we do right here was significant with the angle associated with the trigonometric function. So when we fixed in theta here, that was the angle, the whole angle associated with whatever function we're dealing with. So this theta here, in this case, is 2 theta plus 25. So our theta value here is 2 theta plus 25. So in this case now, we'll be having 180 minus 63. And that will be 117 degree. Don't forget, this value here represents the value for 2 theta plus 25, because that is the value associated with the trigonometric function cos. Yeah. So for the third quadrant, we have theta plus 180. Don't forget, this theta here also is not the same thing as this particular theta here. This particular theta here is just part of the whole angle, as opposed to what you used to have before, where only theta was existing as the whole angle instead with trigonometric function. So yes, this theta here is representing 2 theta plus 25. So in this case now, while trying to solve theta plus 180, you'll be doing 63 plus 180. And what you'll be getting there is 243. Now, don't forget, this 243 is 2 theta plus 25. Now, we have been able to get this angle associated with cos. But when you're trying to solve an equation, you want to find the unknown. So in this case, the unknown here is theta. So we have to then go on to find for theta. So to go on to find for theta, you have to say 2 theta is equals to 117 minus 25. And that will give you a value of 92. So 2 theta equals to 92. Theta here will be equals to 92 over 2, which will give you a value of 46. For this other one, 2 theta here will be equals to 243 minus 25. And that will give you a value of 218. So 2 theta was equals to 218, and your theta will be equals to 218 divided by 2. 218 divided by 2. And that would be a value of 109. So that means in solving this equation, we will get our theta value to be 46 and 109. So that's how you solve questions of this sort. So let's solve one more question, and I would hope you can flow along. So looking at this particular question is quite simple and less complicated. So what you have here is 5 sine y plus 5 cos y equals to 2 cos y. And I need to state that the value of theta here, the value of y here is ranging from 360, from 0 to 360. So how do you find this? Of course, if you can look carefully, you would see that this is cos y here, and this is cos y here. So you can bring both of them to the same side. So you can have 2 sine y will be equals to 2 cos y minus 5 cos y. This will be 2 sine y equals to minus 3 cos y. So what do you do next? Okay, actually the question was for us to solve. So what do you do next here? If you look carefully, you would see that you can I told you at this point you are supposed to find a way to make only one trigonometric function in this equation, and we're having a sine here. We're having a cos here. So this is not possible to solve without making the right moves here. So is there a way we can bring sine and cos together? Yes, there's actually a way. If we decide to divide both sides by cos y, that means if we divide this one with cos y and divide here with cos y, one thing that will happen is this cos y will eliminate this particular cos y, while this cos y will change this whole thing to tan y. So we are having 2 tan y equals to minus 3. Can you see we have been able to have just one trigonometric function? So in this case, you can see that my tan y will be equals to minus 3 over 2. So having minus 3 over 2 gives me a much better way of solving this. So my tan y is equals to minus 1.5. So as I told you already, what you do next is to find y being equals to arctan 1.5. So in this case now, you will be ignoring the sign, and then you'll be getting your y as 56.309. So that's the value for your y. Then you go on to investigate. I told you this value doesn't necessarily have to be part of your answer. You only get your answer after investigating from your quadrant. From your quadrant now, add sugar to coffee. The question to ask is, we have a negative sign here. Where is tan negative? Of course, tan is positive in first and third, so it's negative in second and fourth. So my quadrant of interest is quadrant 2 and quadrant 4. So how do I solve for these two quadrants? The rule inside a quadrant 2 is 180 minus y. In this case, don't forget theta, y, x, it all depends on whatever angle you're dealing with. I'm dealing with angle y now, so I'll be using y. So 180 minus y is the angle here. So I'll be having 180 minus 56.309. That will give me a value of 123.69. While for the fourth quadrant, the rule there is 360. We have 360 minus y. That will be 360 minus 56.309. That will give me a value of 303.69. So you can see that our final solution for this question is that we have gotten our y value to be 123.69 and 303.69. So that's how you solve trigonometric functions, trigonometric equations. It's quite very simple, and I really hope you're able to flow with us, and I hope to see you in the next video. Thank you guys.